The question that I ask myself and audience is if M. King Hubbert was right about the United States, which is certainly a microcosm of the world, we did peak in 1970. It was abundantly clear by 1980 that we had peaked in 1970, and can clear it every year after that. We've been less and less and less oil. Why wouldn't the United States be a microcosm of the world? And he had predicted the world would be peaking about now. Why wouldn't we have done something about that? Why have we continued to behave as if gas and oil and coal were forever, that they would never run out? What we want to do now is to rush out to our public lands, to offshore, to ANWR, and to drill. And I asked them, if you could drill ANWR tomorrow, what will you do the day after tomorrow? And there will be a day after tomorrow. I think about that. I have 10 kids and 16 grandkids and 2 great-grandkids. They're going to be there the day after tomorrow. We're leaving them a huge debt. Check my voting record, it's not my fault. But we're leaving them a huge debt. And I asked, wouldn't it be nice if we left them a little oil? And they smile, and the next minute they're saying, would you vote to drill in ANWR? No, I won't. Or in our public lands, or offshore, until you commit to me that you will use every bit of energy you get from those sites to invest in alternative energy. Because we've now run out of surplus energy. If we had any surplus oil, it wouldn't be $115 a barrel a day today, would it? So I will vote to drill there when I have a commitment that we're going to use all the energy we get there and invest it in the development of alternatives. The next chart is a detailed chart of our production and decline. Here's what M. King Hubbert predicted of Texas and the rest of the United States. And then we've learned to get some gas from natural gas liquids. And huge find in Alaska, big find in the Gulf of Mexico, just a blip in the slide down the other side of Hubbert's peak. The next chart shows some projections of what we will find in the future. Now, although with really good techniques and we have gone out there to a lot of incentives. We've gone out there to look for the last remaining oil deposits. And we found less and less and less as time goes on. What this curve does, by the way, is kind of smooth out those big bars we saw before. Kind of smooth them out. And here we are at this point, and they were projecting how much more we were going to find. And we don't have time, but there's a really interesting metamorphosis that took place here. The USGS, in trying to predict how much more oil we would find, have several computer models, and they put a lot of different data into those computer models, and they get different results out. And they've run many, many simulations, and they put all those simulations on a chart, and they get the mean of those simulations, and they think they're putting in good data, so they should be getting out good data. So they take the mean of those, and they say that's the most probable amount of oil that we will find. So somehow that F for frequency, maybe it was a bad font, but somehow it showed up as a P, or probability, when it got to EIA. And then they make some bizarre applications of statistics. They say that the 50% probability, the green one here, which they say is the mean. Of course, 50% probability is not a mean, it's 50% probability. They say the 50% probability is more likely than the 95% probability. Well, of course, that defies logic, and it obviously is not more probable, because the actual data points have been following, as you would expect they would follow, the 95% probability. I will say again, these two agencies, the IEA and the EIA, do a really good job of tracking what we produce and use. I'd be careful about accepting their prognostications of what we're going to find. The next chart is one from the first big study that I mentioned, one of the 4 that your government paid for and is largely ignoring. This is called the Hirsch Report, done by SAIC, a huge international, very prestigious scientific engineering organization. I've highlighted this phrase because it is so shocking. The world has never faced a problem like this. There is no precedent in history to guide us. We have never faced a problem like this. You cannot go back in history and find any problem that will help you decide how you're going to get through this. And the world has never faced a problem like this. The next chart. They say the peaking of world oil production presents the United States and the world with an unprecedented risk management problem. They say the economic, social, and political costs will be unprecedented. Wow, strong words. The world has never faced a problem like this. Unprecedented risk management problem. Nothing like it in history. Nothing to guide you. The economic, social, and political costs will be unprecedented. The next chart is a schematic. And this shows what we've been talking about. A 2% rate of growth, doubles in 35 years. The yellow there is 35 years. I think we're about here. And notice that the shortfall occurs a little bit before peaking, although the EIA and the IEA both have oil peaking, so we may in fact be about it at that point. Now, most people, when they look at this chart, say, gee, we got to fill that yellow space, because we just got to have all the liquid fuels that we would like to use. I will submit, Mr. Speaker, that it's exceedingly unlikely that we will be able to fill that blank to make up for the deficit between what we would like to use and what will be available. Filling the gap, I think, is not feasible. And what Hyman Rickover cautioned 50 years ago, 51 years ago now, we should note today, and that is that we need to plan in an orderly fashion to move from fossil fuels to sustainable renewables, because geology will demand it. We will move when the oil is not there, when the gas is not there, when the coal is not there. We will have moved to alternatives. Whether that is a bumpy ride or a really bumpy ride will depend upon in the immediate future. The next chart is a really interesting one because it shows us again this rapidly accelerating use of oil, then the recession of the 70s and the much lesser slope after that. Now this chart assumes that we may find as much more oil as all the recoverable oils we now know exists. Most experts believe that there's roughly, will at the end of the day have been roughly 2 trillion barrels of oil pumped. We pumped about 1 trillion barrels now. Most experts believe we have about another 1 trillion barrels to pump. This assumes that we're going to find that we're going to have a total of 3 trillion barrels. Now, if we have 1 trillion barrels remaining of the 2 originally we pumped, another 2 be pumped, and if there's a total of 3, that means that they're presuming we're going to find another 1 trillion barrels of oil. And if we do that, by their own calculations, it will simply move the peak out from around 2000, we're a little after 2000 here, to 2016. That's not very far. That is the effect of exponential growth. During the Carter years, during the Carter years, every year we used as much oil, every decade we used as much oil as had been used of all of previous history. That is a stunning statistic. Thank goodness for those oil price spike shocks and the efficiency that resulted from that. Else we would be in a really troubled world today. Because what that means is if you use as much each decade as you use in all of previous history, when you have used half of the world's oil, which is where we are, then you would have 10 years of oil remaining. Now, we slowed down. So if you do those calculations, the 88 million barrels a day a trillion barrels remaining. That comes out to roughly 30 years. Now, it's not going to be 30 years of constant production and fall off a cliff, because it's going to be harder and harder to get, more and more expensive, getting less and less each year, no matter what we do.